Great. So the first talk on this AI track will be about going beyond prompt engineering. So I'm going to assume most of you have tried prompt engineering or code assistance or ChatGPT or any sort of AI that you might have seen infused in some products you might be using here and there. So I'm not going to really focus on prompt engineering. I'm going to show how you can go beyond by building your own AI applications. First of all, I'm happy to be back. It's actually my fifth time here. So my first talk was in 2019. Then I did a remote one. And then for the last 2 years, I've been doing some GraphQL talks. So maybe some of you saw my talks. That would be really fun because there will be some GraphQL at the end. But yeah, really happy to be back at this great conference and great to see that it keeps growing and people keep coming to Coimbra even though it might not be the place where you live. So this year will be my first sort of non-GraphQL talk because all of these have been mostly GraphQL and this one will only have a little bit of GraphQL in there. So over the past few years, a lot has changed in how we use AI in software development. Maybe you've been starting to play with AI like 10 years ago or 20 years ago already. Or maybe you just started like last year or this year when you found out there are tools like ChatGPT. So to think back, in 2016 or 2015, I don't really remember, I was doing a machine learning course. And in this machine learning course, it was like a 3-day course aimed at like people who already knew some Python but didn't really were really proficient in Python. So I started to do this AI course and what we learned was how to build your own machine learning model. And maybe you've ever tried to build a machine learning model. Today, actually, you don't really need to build one anymore, but more about that later. But in order to build a machine learning model, you need some code, like in Python or Java or JavaScript. It doesn't really matter today. But in order to understand what the code is doing, you need to know about computer science, statistics, mathematics, and also machine learning. And then in 3 days' time, you can build a machine learning model that's able to distinguish between Chihuahua dogs and muffins. So that was AI I was doing in 2016 because the company I worked at, they wanted me to build a recommendation engine for like TV shows or whatever. And in 2016, when you wanted to build a model like this, you always build a model for a specific purpose. So you were building a model to distinguish between Chihuahuas or muffins, or a model to recommend TV shows, or a model to find people similar to yourself if you're building a social media thing. So AI in 2016 was really focused on specific tasks. You're building a model to do something specific. And then if we look at today or 2 years ago, AI has moved away from being very specific to being very generic. So these large language models, they're all multi-purpose. They're focused on a broad scope of things. With an LLM, you can do anything from asking questions about math to figuring out who's your favorite actor, or whenever I don't know, something weird like who's the wife of the president of France. These are all things AI can help you with, even though the model isn't specifically trained to do a specific task. And if you look at LLMs and you want to make LLMs smarter or better for your use case, you need to do some tweaking. And there are some things you can do, like prompt engineering, which you maybe have tried. And then there's other things like making AI context aware. So in most part of this talk will be focused on making AI context aware, on helping it to become better at your specific task. So as we moved away from models specifically trained to do a task, we now have models that are trained to do everything. And as developers, we need to find ways to make these models built for everything work better for our very specific use case. So it's a bit of a upside down from where we started. And on the right, you can see also a code assistant. So let's look at code assistants first as well, because this is something I'm using almost every day. Is any one of you using a code assistant? Oh, nice. A lot of you are. That's good to see. So I use code assistants almost every day, and the code I'll be showing you today was also partly written by code assistants, or at least suggested by code assistants. I use it a lot to generate mock data. So whenever you start to build something, you probably don't want to connect to APIs already or connect to a database. You just need a bit of JSON or whatever type of mock data you're using. You can also use it to optimize existing code. I don't really do this because I usually have it generate code and then I redirect the code. And also for stuff like debugging. Sometimes you can see an issue, something doesn't work, and you can just ask a question for a specific code block to help, for example, GitHub Copilot help you. So I used a lot to generate mock data in situations like this, or to write tests. And in case you wonder, and this will also be continued in the rest of the talk, in order to generate code for you, GitHub Copilot, for example, it won't look at your entire code base because it's too much information. It will only look at the open tab. So if you're writing a test, for example, you can import the function, and then it will be able to retrace its steps to that specific file. But even better will be to have a separate tab open in which you have this file opened. Is this dark code? Is it visible from the back? It is? Okay, that's good. So I use it to help me generate code, to write tests, and mostly these things. So one important thing to keep in mind when using GitHub Copilot or other code assistants, keep a tab open with the code you wanted to base its responses on, because it needs context in order to have better answers to your question. Because it's trained on a lot of code bases, but not specifically the code you just wrote. So make sure to either import or have this tab open. So we're trying to make LLMs context aware. And in this talk, I'll be showing you how you can build things like this yourself. So a little bit about myself. My name is Roy. I used to work for a nice GraphQL startup called StepSam. We were acquired by IBM. So I've been working there now for a little over a year. This was me at the GraphQL Conf last September. So maybe you'll know where my interest in GraphQL comes from. I wrote some books, and I also put videos on YouTube. So if you want to know more about what I do or technologies I use, feel free to find me there. If you didn't visit JNation before, then also go to YouTube to their channel, because they actually post all the videos there. So if you're trying to figure out what people spoke about last year or the year before, you can find all of that on YouTube. So that's a good thing to know. I'm also more than happy to connect with you on social media or whenever you find me in the hallways of this conference. So AI has changed how developers write code. I already saw that a lot of you are using code assistants, so it probably also changed the way you write code. You're using code assistant, you're using chat assistants, you get help day to day. Maybe otherwise you would have went to Stack Overflow or just Googled something. You ended up on some weird forum where people were discussing this specific issue you're facing like 5 years ago. So AI has already changed how we write code, but do you actually know what's happening under the covers? Does some of you try to state that they know what's happening whenever you ask a question to an LLM? Maybe some of you feel confident to say that they know. That's good. Someone thinks they know. Someone thinks they might know. Well, probably all of you know because you know how to write code, so you can probably imagine there is some back and forth between a backend, and then there would be a backend that does something. But yeah, later let's see if you actually know. So let's look at a typical code assistant or a chat assistant flow. So you have a question which you will type, it will end up at the LLM, and you will get an answer. And in between, a lot of things are happening, or could be happening, or are supposed to be happening. I mean, if you're writing code, quite often what you want the code to do doesn't actually is what the code ends up doing. It's the same when you're building AI applications. So if you have a question and an answer, we like to call this like a QA thing. There is always some code in the middle. And this code in the middle will determine what's going on. There could be very simple code in the middle. Maybe it's just an API call to an LLM. Or there could be really complicated code in the middle where it might do multiple calls to LLMs. It might do calls to different LLMs. It might goes to a database or goes to different sets of APIs and then returning back to the original code that you have in between. So in between your question and your answer, a lot of things can happen, but it can also be really simple. And what happens in between often ends up being still the same things we did in 2016 when building AI. You need computer science, statistics, mathematics, and machine learning. But the good thing about living today is that you don't actually need to know all these things, because there is also APIs and wrappers and SDKs to interact with models, so you don't have to build them yourselves. But it always is useful to know more about what's going on under the covers. I always like to say there's two types of developers that play with new technology. You have developers that use it, and then it works, and then they say, great, it works. And then you have developers that, before they actually try it, they will go to the documentation, they will look at the code, they will look at tests, and then they actually implement it. They make it work, and then they try to be the best at that specific technology. I'd say I'm somewhere in between. So I always try to use something. If it works, it works. I don't really care about it anymore. As soon as it starts breaking, I'm going to find out why it breaks and how it actually works. So if you want to deep dive into the covers, you actually need to know mathematics, computer science, statistics. But you don't have to. That's one of the great things of being a developer today. So you don't have to be a data scientist in order to work with LLMs, in order to build AI applications. I think it's some sort of misconception that you need to be a data scientist or a data engineer in order to understand what LLMs do and how you use them, because it's just code in the end. So there's a term that the internet, likes to call AI engineers. These are developers that work with AI. They implement code based on AI. They implement code around AI, but they don't necessarily build the AI model. So there's a huge distinction between building models and building implementations of LLMs, AI, everything around a model. And the internet likes to call this AI engineer. Maybe if you go to LinkedIn or Twitter or whatever sort of job vacancy board where you will find job roles, you're probably going to see more and more AI engineers there. I think when ChatGPT was released, we had a meme going around on Twitter where people said, in a few years, we will all be prompt engineers. I think we're well beyond that point. Prompt engineering is important when you work with AI, but building applications, implementations around AI is getting more important than just doing some prompting. And for this, we make use of all these foundation models, which we like to call LLMs. So there is a ton of different models available. You have the GPT models from OpenAI, you have the Lambda models from Google, which are now actually rebranded to Gemini. Then there are the Llama models from Meta, and these are actually one of my favorite ones. They're open source, so in theory, you could run this model on your own machine. I have a video of this on YouTube on how you can run your own model directly on your machine. It takes a couple of gigabytes, so it likes to get slow, and if your computer doesn't have the best GPU, then it will actually be slow. So I work at IBM. We have our own models, which we call the Granite series of models. And then you have Claude from Anthropic, which is also a really good model. And then Amazon has their own models as well. So basically, a lot of companies are releasing models. So you don't have to stick to one model. You can use all of these different models side by side as well. So it's really good to know that you don't have to be a client or a customer of a specific company. You can run your own models. You can use open source models that are running on tools like Hugging Face, which is some sort of a model provider. And then there's all these models you can directly get at its origin. And the way we access these models is through APIs and SDK. So APIs are a really easy way to work with models because everyone knows, at least most developers know, how to make a call to an HTTPS endpoint using curl or using fetch or using whatever sort of library in your programming language of choice. Most of these providers also have SDKs, which are in Java or JavaScript or Python. So LangChain is a popular open source library, which is available in JavaScript and Python. And using this library, you can actually wrap all sorts of LLMs from different providers and get some sort of abstractions on top of it. Then OpenAI has its own SDK, I believe, as well. But they also have API endpoints. So instead of using ChatGPT to get answers for your questions, you can also directly call their models using an API endpoint. And then at IBM, we have something called watsonx, which is also a platform to run models. So you can, for example, you can get the Llama models from Meta through watsonx if you would want to. And then on top of these APIs and SDKs, you can still build your own front-end, back-end, like integrations between systems, whatever you prefer. So in a bit, I'm going to have a small demo on how you can basically do the application part. And if you work on a front-end, for example, I like to use LangChain because it's JavaScript, and most front-ends today are JavaScript. As I said, they also have Python. So as originally a lot of the work around LLMs was done by data scientists and data engineers, a lot of code to work with LLMs is in Python. But it's getting more and more adopted in different languages, such as JavaScript, but also in the Java and .NET world, you see a lot of new libraries popping up that help you to work with these different LLMs. So as said, you don't have to be a data engineer or data scientist. It's available in all sorts of programming languages. Meaning that every one of you that knows how to write code is able to build AI applications and work with models and build your own applications around it. For example, if you use JavaScript to build front ends, you only need to do 2 npm installs, which is LangChain. And then if you want to use models from OpenAI, which are generally speaking the cheapest and easiest models to get, you just need to install 2 libraries and you're able to run the system. And when you install LangChain, there's multiple things you can do. You can follow their getting started tutorials, you can browse the internet and figure out how to build something. But what are you actually going to build? Because doing an API call to an LLM is a simple thing. You put a question in your body of your HTTPS request, and then you will get an answer back. But this probably isn't the most sophisticated thing you can build, because doing this sort of straight call to the LLM just involves some prompt engineering. So I'm going to quickly show prompt engineering, just because we're here and this talk is called Going Beyond. So we need to know what are we going beyond of. So prompt engineering is basically engineering the prompt that you send to the LLM. So a prompt itself, it's something that's called a natural language task, describing the task that an LLM should perform. So your prompt, it contains your question to the LLM, but it also contains a set of instructions. And with prompt engineering, you're not only shaping your question in a way that it can be easier answered by the LLM, you're also structuring the instructions. And maybe you're also giving examples, or you're giving more context. Like maybe you have a bit of text that you want the LLM to base its answer off. These are all things you can do, and it's what we call prompt engineering. So it's not only asking a question, but it's also providing a bit of text around your question in order to get a better response. So it looks a bit like this. You ask your question is wrapped in a prompt. So if you use ChatGPT, the question that you type, before it reaches the LLM, it will be injected into a prompt. So even though as a developer or as a person using a chat assistant, you don't really know that they're taking your question and wrapping it in a prompt, which also includes instructions. So that's why, generally speaking, if you know how to work with APIs and you're using ChatGPT, I would actually recommend to go to the platform behind ChatGPT, which is the platform from OpenAI. And then you can actually structure your own prompts. So instead of asking your question in the code assistant or chat assistant, you can put it in a request to the API, and then you can also give instructions. So this is a really useful way to help the LLM give better replies to your answer. An example here would be, let's assume so I had to travel here to Coimbra. We got some help from the conference, of course, but suppose you're not getting help from a conference or from someone else to visit to a location. You can ask the LLM, like, take the role of a personal travel assistant. And by doing so, you're already giving instructions. And then you can say, answer the following question in detail. So you're asking for a detailed answer, also from the role of a personal travel assistant. And then your question is just a variable. You put it inside the prompt. So this is what we call zero-shot prompt. You don't give any examples, and you're going to assume the LLM is capable of giving you a good answer to this question. And this will work for general purpose things. Like if I would ask for recommendations for Coimbra, there's a fair chance that it knows about the university or the botanical gardens or maybe the river. If I ask a question about, I don't know, maybe famous citizens of Coimbra or laws in Coimbra, like can I build an additional story on my house? These are probably things that need additional information, so I would need to provide some examples so the LLM will be better in giving me an answer. If you want to build this, like very simple prompting in LangChain, if you were to write JavaScript code, and for Python it looks similar, You just need to import the libraries. You then connect to OpenAI, so you need to provide your API key there. Then you create your prompt template, where you basically put the instructions, and then the question becomes a variable. So if you are building a travel assistant application, for example, you define the prompt template somewhere in your backend, the person writes a question, and the question gets inserted inside this prompt. And then the only other thing you need to do is send this prompt to the LLM and collect the response. So it's only like, let's say, 8 lines of code in order to build your own connection to a model from OpenAI in this case, but LangChain works with models from all sorts of providers. And basically, this is all the code you need in order to build your very first AI application. So there isn't too much code involved, and I'd say most developers would be able to do this. If you're able to send questions, if you're able to send requests to APIs or send questions using SDKs, then it's just these 8 lines of code. If you want to build something more, a little bit more sophisticated, and this is still prompt engineering, I promise we'll go to more sophisticated examples later. Let's say you still have this personal travel agent application that you're building, and this time you don't want it to answer the question in its own creative way. You want to give a format for its reply. So what you could do is you can give it a set of examples, like input-output. So by phrasing my output like this, it's always going to return part of your question, and then it's going to give just a list of responses. So 1, 2, 3, these are my 3 highest rated restaurants. Or this is the best season to visit in summer. So I'm going to give it some instructions to give me answers in this specific format. And this is all still prompt engineering because I'm giving the LLM very specific instructions. And based on these instructions, the LLM will help me generate a question. So this is what we call few-shot prompting. You're giving a few examples, and based on these few examples, the LLM is going to give you the best possible result according to its own knowledge, of course, because right now the LLM is still trained on general purpose data. We didn't give it any specific context or specific information about the places I'm trying to visit. There is a couple of more examples of prompting you can do, and I'll talk about prompting as a talk on its own. So I'm not going to focusing too much time on this, but there's a QR code you can scan, and this will bring you to an online source which is called promptingguide.ai, and they have all sorts of examples for prompting. There's chain of thought, for example, where you sort of go inside a conversation with the LLM. You ask a question, you ask a follow-up question. You're going to give it examples like, in the case of A, please provide this. In the case of B, provide the other sort of follow-up questions. There's a tree of thoughts. There's self-consistency, where you hope to make the LLM self-consistent. And then there's something called react prompting, which I'm going to circle back to at the end of this talk. Because in react prompting, you're going to ask the LLM to react based on a specific task you've described in your question, which is kind of interesting. So I'm going to give you a few more seconds to scan the QR code in case you want to know more about prompt engineering. So the thing I really wanted to talk about is not prompt engineering or how to interact with LLMs. It's also how to make LLMs aware of your own context. So in the very beginning, I showed you the machine learning model I built like 8 or 9 years ago, where I was training a machine learning model for a very specific task. I wanted it to distinguish between Chihuahua dogs and blueberry muffins. And today we have LLMs that are trained on general purpose data. So in order to make an LLM smarter on figuring out a specific task, we need to provide additional context. And one popular way to do this is called RAG. So this is retrieval augmented generation. So this is where you give the LLM context that it should use in order to answer your question. It's a bit more complicated than the previous, where we just sent a request to the LLM wrapped in a prompt. So what we do this time, we're going to use a vector database. And has any one of you ever used semantic search? Like other than keyword search, just semantic search. Maybe if you build a search engine or you use things like Elasticsearch. These are all examples of vector databases. They vectorize your question, so they make vectors of it, And then based on these vectors, it's trying to find similar vectors in its database. So if you build a search engine and you ask about, you ask multiple words, or maybe you ask a specific question in Google, for example, they used to use vector databases before they were injecting AI in there. So what it does, it takes your question, it turns it into vectors, which is just representations of words or characters or tokens in numbers. And for this, it uses a embedding model. So if you build RAG, you always need an embedding model. And then it stores these vectors in a vector database. And as these vectors are available in your vector database, whenever you ask a question, it's able to look at your question, trying to find related vectors from the vector database, inject these back in your prompt together with a set of instructions before it goes to the LLM. So here there's actually multiple things happening. It goes to a vector database, it tries to find related context, and then it's going to put this related context in your prompt. So together with the question and set of instructions. And only then it's going to generate an answer for you. So there's an additional step here, which is the vector database. And the vector database is one of the most important things here because it helps you to find related context. So the way you, actually before doing RAG, you need to take an additional step. You need to upload data to your vector database. And this could be data, it could be all sorts of data. It could be hundreds of PDFs, it could be millions of PDFs. It could be data you pull from a database, store in a different format, and then inject into the vector database. If you are a bit more closer to the sort of the data world, you might have a data lake that you put inside a vector database or that you know how to vectorize somehow. So what you would do here, you take your data set, you turn it into chunks. So chunks are smaller sets of data, so they are easier to upload in the vector database. And then they get stored in your vector database after you use the embedding model to create vectors. So the way to think about chunks is, chunks are basically a row in your database. So you turn your large set of data into maybe millions of rows of data, because you don't want to have too much data, otherwise it will take longer for the LLM to process. And then as soon as they're stored in the vector database, you can already retrieve them using vector search. So if you're looking for maybe tips about Coimbra in Portugal, if you use regular search, it's probably always going to look for Coimbra and Portugal in the same sentence. Whereas semantic search would be able to also look for Coimbra and Portugal separately. So that could be one easy way to think about semantic search. And LangChain can actually do all this for you. So I already showed how to use LangChain for some basic interaction with the LLM. LangChain is also able to vectorize your data, store it in a vector database, connect to the vector database to retrieve its data, and then again do the very simple prompting we saw before. And for this you only need a bit more of code. I'm going to show the code again later, but I'm just walking through it now. So what you need to do, you need to take your training data, and I'm going to have an example with just one small text document, but this could be millions of documents actually. But as you probably know, if you want to load millions of documents, you probably need to set up some ETL in order to do this efficiently. And I won't be able to do that for a small demo. And then I need to split the text into chunks. And chunk size is something that's quite important here. Because the larger the chunk, the more data will be in those chunks, the harder it will be for the LLM to get relevant chunks for all the questions you're asking. And then you need to store it in a vector database. And again, you're using the embedding model here. So the embedding model that you use to store your data should also be the same embedding model that you use to retrieve your data later on, because it's important to create the vectors. And then again, you can retrieve this building something that's called a chain or a flow. So a chain or a flow is basically the sort of overview I gave of RAG. Your flow is retrieved from the vector database, inject into the prompt, sent to the LLM, and then generate my question based on that. And in LangChain, these are called chains. In a lot of other libraries, they are called flows. So let me show you an example of this. For this, I go to VS Code first. So I have a small application running here, which I like to call my GPT. And tomorrow I'm doing a workshop in the morning. Maybe some of you have signed up for that one. In this workshop, we're going to build this application, and we're going to do more things, of course. But I'm also going to show you what it looks like. So I have one file which I call langchain.ts. I'm importing some libraries from LangChain. So this is JavaScript, but you can also do it in Python. I'm connecting to OpenAI. I'm setting something called temperature. So temperature is a way to let the LLM know how creative it could be. So a temperature of 1 means it shouldn't be creative, it should stick to the facts. And then I'm defining which model I want to use. If you're looking to use this in a production environment, make sure to test different models, because different models can have different responses. They can also have different latency numbers. So the newer models, they could be quicker than the older ones. They're also more expensive than the older models. So it's always good to think about what sort of gives you the best results based on efficiency, but also based on price. So what I'm doing here, I'm storing some data in a vector database, and this is an in-memory vector database. If you only have a small set of documents, it might be worth it to load this directly, store it in a vector database, and use it in the LLM. So this is used a lot in something that's called chat with your documents. A lot of companies build these chat with a document implementation. So maybe you have a terms and condition document that's 10 pages long, and you want to know if there's something about a cancellation policy, or maybe about complaints, because you want to file a complaint because you're not happy with a specific service. What you would do, you would fetch that document, you would store it in memory in a vector database, but if you have large number of data sets, then you can also store it in an external vector database. You split it into chunks, and then you store it in the vector database, and whenever you generate your answer, you have your prompt. So in this case, I'm saying my prompt is take the role of personal travel assistant that answers question in a consistent way. And then you can give it some examples, like format it like this, and then you can do some more prompt engineering here. And in the end, you're chaining it all together with the context. So I want to answer the following question based only on the provided context, which is this context coming from the vector database, and then my specific question. So you're putting all these things together. You're putting together prompt engineering with data from a vector database. And then these are still like 100 lines of code, which is quite a lot. And I have it running somewhere. So let me first show you the data, so you know what the data looks like. So this is my data. It's a blog post about the top 20 things to do in Amsterdam. So I'm living in Amsterdam, and I can confirm these are pretty nice things to do there. There are also the more touristy things, but it's completely fine for this example. And somewhere in here I said, answer the following question based only on a provided context. So I have my application running in my browser right here. So this is a very simple app that I built, and it's just connecting to an LLM using LangChain. So I can ask it a question like, what are the best restaurants, or museums, maybe museums, in Amsterdam? So what it will do now, it's a bit slower than you might want it to be, because it first fetches my data, it puts it in the vector database, the in-memory one, and then it uses my context. So based on the provided context, the best museums in Amsterdam include these ones. So if I would go back to my text, I can probably find all these different names. If I'm trying to do something else, like what are the best museums in Coimbra, it should actually fail, because I'm asking it only to use the context and not the data it has been trained on. And then you can see the answer is like the provided context does not mention any museums in Coimbra or relate to Coimbra in any way. So this is a good way to make LLMs context aware, and also by doing some prompt engineering, have them focus only on the specific things you want them to focus on. And this will really help, because at some point I was using my sleep tracker, which I thought was a good idea to get better sleep. In the end it wasn't, but that's fine. My sleep tracker had a function to analyze my sleep. So it could figure out based on sounds, like how well you slept. And then they had an AI feature that helped me analyze my sleep results. And it was able to analyze my sleep results, but I could also ask this AI feature, like, what are the best places to visit in Coimbra? And it will return the best places to visit in Coimbra because the model it's using has been trained on general purpose data. So if you don't do prompt engineering when you make LLMs context aware or when you implement them in your products, it's going to spit out all sorts of things that are irrelevant to your specific use case. So prompt engineering is useful for that specific thing. So we saw the LangChain code. To build a RAG application, a LangChain was like 100-something lines of code. And this was only the backend. So it's the calls to the vector database, connecting with the model, constructing the prompt template. You can also do this with less code. There's a lot of things happening in sort of this space. Myself, I'm also working on a new product, which we call Flows Engine. And this basically means that we are going to define all the steps of doing RAG, of doing QA, in just a simple flow. So you have step 1, 2, 3, or 4 or 5, no matter how many steps there are, all in a sort of abstract way instead of needing to write all this code. And it's a good thing because it's making it even easier for you to build AI applications, even when you don't want to build the entire backend yourself. So I can give you a quick demo of what this looks like. I probably have this here. So the only thing you need actually is this file, which contains flows. So if we look at RAG, for example, this could be an example of a RAG flow. You have your inputs, so this would be your prompt template, your question, maybe the temperature, things like that. You have your top-end docs, which is retrieving data from the vector database. If you retrieve data from a vector database, usually you don't retrieve one chunk. You maybe retrieve 2 or 3 or 4 or 5. And if you want to retrieve more or less chunks, it would also influence the quality of your response. And then it's going to put your context together with your inputs in a prompt. It sends it to the LLM, and then it's going to generate an answer for you. And the only thing you need to build this is basically this thing you have right here. You can also set it to upload your own data. So for example, I'm using a data set here that's very general purpose. It has information on music, it has information on wars, it has information on, I think, even presidents. So yeah, there's like 180 references to presidents. So this is a general purpose data set that could also be used to train a specific model. So in order to upload this, I need to run just a command that says collection deploy. So this will deploy my collection to the vector database. This can take some time depending on the size of your document. Like this is like 28,000 lines. But what it does, it computes embedding vectors to store in a vector database. It's going to put it in the vector database. And I can actually stop this command because it's going to take too long. And then the thing I need to do, I need to deploy my flows. So these would be my flows to retrieve data from the vector database. It deploys it to an endpoint. And then the endpoint, I'm able to use this endpoint in multiple ways. So I can use this endpoint using an SDK, much like here. So in 25 lines of code, I will be able to retrieve all the information. Or I can also, and I told you in the beginning, I'm going to show some GraphQL. I can also retrieve the information using GraphQL. So this is just a question based on my collection, which was the very long data set I showed. I have a question like, who are the interns in Grey's Anatomy season 9? So I'm going to assume there's some information about Grey's Anatomy in my, my data set. If I search for it here, it's probably spelled differently. There's some information on Grey's Anatomy in my data set. And then I'll be able to ask questions like this. I can set parameters. And this time, I'll be able to create my own flows or chains using a line of abstractions. And then I'm able to ask questions using an API or SDKs. So this is a simple way to build your own RAG applications, because if we go back here, there's more things you can do than just build a simple RAG flow. There's also things called re-rankers. So sometimes you get information from the vector database, but you want to re-rank the results, because maybe you feel the results are ordered indirectly. And sometimes even you want to revalidate your context. So you might have results coming from your vector database, and instead of injecting them in your prompt already, you first want to verify them using another set of LLMs. So using a flow language like this, you would be able to do something like verify top and docs, like this. You would save it and then you redeploy it. And this is very useful if you don't want to major in building RAG flows, you don't want to major in building AI flows or chains, but you just want to use them for a specific purpose, like building your product or building your own code assistant, then this will help you to move faster. So this is a new product that we're building at IBM, also using some of the Watson-X models. There's a public preview, so if you would scan this QR code, you would be able to sign up, and then you get a message when we finish the product. But if you have any questions, then feel free to find me. So I showed two ways to build it. You can use tools like LangChain, which are open source, and you can connect them to most models. They do require a bit more code. And then there's new frameworks popping up, like this one, which would involve writing less code, and you can even deploy them to the cloud. And then a good thing to know is RAG is not the only way to make LLMs context aware. Because for RAG you need to build a flow, you can generate flows, or you can use things like LangChain. You can still do training or fine-tuning of your models. So let's assume you have a very specific purpose. You can take an LLM and you can actually fine-tune it by providing a large set of data that you want the LLM to specify on. So in the case of building a code assistant, you could take a general purpose LLM that's already trained at code, and you can feed it like your entire code base, and then have it fine-tuned based on your code base. So by doing so, the LLM will get smarter based on your code base, but this will take longer and is quite expensive. So unless you're like a company with 10,000s of people or making a lot of revenue from these specific LLMs, it doesn't make sense to do this. So you're more looking at RAG, or maybe long context windows. Because long context windows is also interesting. You might have seen the announcement from Google that they were able to do like a 8 million or 8 billion parameter model. So this means that if you're thinking about long context windows, you won't need RAG because of inserting chunks from your vector database, which are the best fitting chunks based on your search term. It will actually insert all the data directly inside your prompt. And this is fine if you are Google and you have very fast computers, you have models running on your own GPUs, and you don't care about the cost. But if you're building like general applications using AI and you're not working for a company like Google, you can still use long context windows, but be aware it might be expensive or really slow. So that's why we have things like RAG set up. And then the final thing I wanted to present you is AI agents. So we mostly looked at prompt engineering and RAG, which are still sort of deterministic or rule-based. You need to build these flows. You need to build a RAG flow where you go to the vector database, inject it in your prompt, and you define all this yourself. So you have sort of control over the end result. Something that's popping up like for the past 6 months or so, and a lot of frameworks are implementing agents, but it isn't as sophisticated as building RAG. So with LangChain or with this flows engine, you will be able to build agents. But there's still a lot of things happening and still a lot of moving targets for this. But AI agents are, I'd say, more or less the future in building these AI applications. So if we go back to our question and our answer, there is something happening in between. I showed like deterministic ways that are happening in between. These are rule-based. But with agents, it's not so much rule-based. So I have a diagram here. I'm going to take some time to walk you through it. So you have your question. You ask it to your system, which isn't directly an LLM. It's a system built around an LLM. You ask your question like, what are a good one could be if you're building e-commerce. I've been doing a lot of e-commerce in my career, more than I wanted to, maybe. But let's say you want to retrieve today's orders and the tracking numbers of the packages that were shipped. If you do this and you work for the e-commerce company, you probably know you send a request first to one API and then to another API in order to retrieve first the orders and then for all the orders the tracking numbers. If you ask this to an AI application, the application would look at your question and it then needs to think or plan what it should do. Because it should do follow-up actions. It should find orders first, and then maybe tracking numbers, and then put them together in a coherent answer. So in order to do this, it will need a set of skills or tools. So as I said, AI agents is still like a new pattern. Some people like to call them skills, other people like to call them tools. So maybe you tried this in ChatGPT, where you put a URL in there, and then it's able to go to the URL and then retrieve data from the URL. But you still have control because you provide the URL. If you think about building agents, you would provide the LLM application or the AI application with a set of skills. So these could be functions or API calls that it would be able to do itself. It could also be Python code or Java code or TypeScript code that it's able to execute because you provide the LLM with a runtime. And based on your question, it's going to look at the set of skills it has, like going to your order management system or going to maybe DHL or UPS or whatever you're using for shipments, or executing a Python function that you provided a runtime for. And then it's going to act. And not only act, it's going to react. So it can act first, so it can retrieve orders from your order management system. And then depending on the results, it should maybe go to UPS for some orders, to DHL for other orders. And maybe for some orders, it should go to a different system because it's shipped manually, or it's going to be delivered like by someone from your company. So it's not only acting by getting the information, it's also reacting. So based on the information the skills return, it's going to take separate actions. And within a chain, or sort of this flow, it could take different actions based on different responses from these skills. So it provides you with the answer. And then there's also an observability part, because it's going to look at your answer and it's going to figure out what it can do next time better. So these are agents. We sometimes also call them autonomous agents, because you provide the skills, but the LLM itself is going to determine which skills it uses and in what order. So in the near future, I think we'll be building these agents. And if we go one step back, personally, I think RAG will be one of those skills. So a skill of your agent could be go to my vector database and retrieve relevant context because someone uploaded a data set that would make sense for this. So maybe terms and conditions or invoices that you have for specific customers. So RAG will become a skill in the sort of world of autonomous agents. So the very short summary of this talk, I'd say, is building AI applications is just like building any application. There's code involved. There's some patterns, there's some concepts that might be new, but most of it is just API calls and SDKs. Something I like to say is LLMs are just an API call away. You don't need to run them on your own machine. They're everywhere. There's APIs, and a lot of different companies are providing access to LLMs using these APIs. So that was it. The QR code will bring you again to the new product we're building in case you're looking to find out more. Also find me on social media or find me here at the conference. So thank you.